So welcome to the February PyData Meetup Ann Arbor. To start, I just want to acknowledge our sponsors. So NumFocus, which sponsors the meetup, TD Ameritrade for this beautiful space, and Midas, who provided the food. So some points. So emergency exits are both back the way you came and over here. You can provide feedback to any of the meeting organizers, myself, Rose, Sean, and Ben. We also have a GitHub, which you can find here. In addition to Twitter and Gmail, you can provide feedback there as well. We are in a borrowed space, so please clean it up after yourself. A couple of notes on Q&A. So unless quick, hold questions until the end. Please phrase your question in the form of a question. Try to keep questions to 30 seconds or less. Avoid long statements or monologues. And a reminder that there will be time for open discussion after the Q&A. So I'm going to read our PyData Code of Conduct. PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, religion, or experience. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds and levels of experience. Sexual language and imagery is not appropriate for any of our meetup events. Be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers. Thank you for helping make this a welcoming, friendly event for all. So we're going to do a quick icebreaker provided to us by Amy. So turn to someone next to you that you don't already know, introduce yourself, and we'll talk for a little bit about which do you think is more likely, UFOs or Bigfoot? So this month in data science. So I read a little bit about this as homework for this, but there is an interesting discussion forum here. So there was a petfinder.my Kaggle contest, and the first place winner was disqualified. So there's an interesting conversation about sort of the ethics of data science and how we as a community can be working together in order to sort of further, especially this cause was for, helping determine how long it takes animals to be adopted out of a shelter, right? So for a great cause, and folks sort of took it and did some bad stuff. So very interesting read, a great instance of the community coming together, and also people ultimately, being honest, and they returned the money. I don't know. That's good. All right. So our next event. So our March meetup will be Shannon Axelrod from the Chan Zuckerberg Initiative on building software for biology research into the cells. So that will be Wednesday, March 11th at 6 p.m. also here. So now it's time for our community announcements. So for the folks that are new, every month we have the opportunity for the community to give announcements. So if you are hiring for somebody, if you're looking for a job, if you're hiring for a job, if you have other meetups or other events or really anything that you think would be relevant to the PyData community, feel free to stand up, introduce yourself, and talk about it. Barry.
Hello, I'm Barry DeSico. I'm one of the co-sponsors of the Ann Arbor R Users Group Meetup. We're going to have a meeting tomorrow at Spark, which is about 2 blocks away. I'll be giving a talk on how to get up and running with R Studio on AWS. It won't be a deep talk in AWS because I'm just learning it. It'll be as deep as my experience.
What time is it?
You're 6:30. Talks at 6:30. At Spark, we'll provide pizza. And we're looking for speakers. So we've got one lined up for March if anyone's got something wants to give a talk on our related topic. And April and May, where we're having that.
Great. Anyone else?
So on behalf of the AI Lab at Michigan, we started last year and we do it every other month, Friday night AI at the library. And I think it's a fun event also for family and friends, not only for people who are technical, to learn more about what's happening in AI at Michigan. And the next one will be March 13th, so after your next meetup. And that will be on building conversational AI. And it's at the downtown library in the multi-purpose room. And you will find it in the Ann Arbor Observer.
Great. And what's your name?
I'm Radha Mihalchak.
Well, welcome. If anyone has any questions, I can talk to you afterwards.
Hi, I'm John Dennis, and I'm looking for opportunities for data science and machine learning. So if you got some openings, if you want to chat, see me afterwards. Thank
What are
you.
your data science interests?
Oh gosh, how much time do we have? I love anything unsupervised learning. Very interested in NLP kind of stuff. Super excited about it. I've done a lot of projects and just interested in seeing what's out there.
Great, thank you. Any other announcements? Great. All right, so in this talk, Amy will walk through how to use the TextRank algorithm for summarization, and she'll demonstrate its application with a real-world use case, summarization of news articles. So, Amy, take it away.
Hi everyone, I'm Amy Hemmeter. Whoops. I'm an artificial intelligence engineer at Interactions here in Ann Arbor. We're located in Carytown. We work exclusively with NLP for our AI group, and we also mostly make chatbots, though we have some other products as well. So that's sort of why I'm here to talk about an NLP topic, how to do summarization of news articles using TextRank. And actually, if you are interested in NLP, we have a meetup on the 27th, and that QR code will take you to meetup.com where you can RSVP right now. So if you want to do that, you can while this QR code is up. It's going to be Brian Lester giving the talk, my colleague. It's called Your Neural Network for NLP is Probably Wrong. And he's going to talk about some common mistakes people make using deep learning for NLP, including padding, which is why we have that picture. That's a real picture from Facebook. Some bad machine translation in one of my pug groups. So that is on the 27th. It's at Spark, which, as Barry mentioned, is just a couple blocks away. And that's another thing you can check out if you're interested in NLP. Okay, so this is another QR code for the GitHub repo for this talk. So this repo will include everything you need to reproduce this talk. It'll include a PDF of these slides, as well as the data that we used, the script I used to get the data, so you can change the source if you want and get your own data. You can change the keyword I used and get your own data. You can play with it however you want. And then it also includes the Jupyter notebook with the code that I used for this talk. So if you want that, grab it now. And if not, we will move on. Okay, so let's jump into the problem. You want to follow a keyword in the news, and you want to get updates about that keyword. Just to clear up any confusion right now, this means like a search term, not keyword extraction, which is another kind of summarization. So that's what I mean when I say keyword here. We're not going to talk about keyword summarization in this specific talk, though you can also use TextRank for that. So you want to follow a keyword, and you want to get news updates about the keyword. You want to get 20 articles that pop up, but you don't want to read them necessarily. You just want to get a sense for what's happening. So how do you solve that problem? You can use summarization. So our task is to get 2 to 3 sentences from each article that sum up the content of this article. In our case, we're actually going to use 2. This is also called extractive summarization. There's also a type of summarization called abstractive, where you can generate new sentences and phrases, but that's beyond the scope of this talk. So we're only going to talk about extractive summarization of full sentences, not keyword summarization or generating new sentences. So we want to get 2 to 3 sentences. How do we determine which of the sentences are important? We can use a tool called TextRank, which you may have defined from the title of this talk. It's a paper originally by Mahalcha and Tarao in 2004, and we're going to get into all the details pretty soon. It basically does exactly what we want to do for our task. It ranks sentences, so you can choose the top n sentences for your summary. Again, we will be using 2. It can also be used for keywords, but we won't be doing that today. And it draws its inspiration from Google's PageRank algorithm, which begs the question, what is PageRank? And I apologize in advance. If you're familiar with PageRank, this is going to feel a little bit like I'm beating a dead horse. But I want everyone to come out of here knowing how PageRank and TextRank works, so I'm going to try to go step by step. So let's pretend you have an internet of 3 web pages, right? You have links between those pages. The first is from here to here, and it also links from here to here. So that's one web page linking to 2 other web pages. And you have one more link from the gray one to the bottom one on the bottom left. Using these links, we can imagine ourselves as a theoretical web surfer. So you start with the probability of being at each node, initialized to either some random value, or you can use a simple proportion of the overall probability. In this case, it would be 1/3 for each web page because we have 3 web pages. So the algorithm for PageRank iterates through and pretends to be this web surfer clicking through. And each time, the web surfer clicks through at random with the new probabilities based on the update that we'll talk about soon. By the time the algorithm converges, and again, we'll get to this in a moment, the web surfer should end up here because this is the page with the most links to it. And this would be the second highest ranked page. This is the general idea, super simplified, but we're getting into a little bit more nitty-gritty once we get to the PageRank update formula. So we're just going to provide some familiarity with the original formula so we can make comparisons to TextRank. VI is our target node, and SVI is the score for that node. So this is the score that determines how important the web page is. In VI is the set of vertices that point to VI in the graph. VJ is one of the nodes in VI, since we're summing over all of those nodes. And that's the source node for this part of the update as we sum through. SVJ is the score. So we're also not only taking into account the scores, the edges of the other nodes, but also the scores of the other nodes. So a recommendation from a node with a lower score is not worth as much as a recommendation from a page with a higher score. And then this part represents the number of edges going out of VJ. So this part normalizes for pages that have a lot of links going out. So if we have these so-called linky pages, we want to weigh them as less important than pages that only use a few links, because in theory, the ones that only provide a few links will only provide links to the most important other pages. Okay. And then finally, D is a damping factor that can be set between 0 and 1. It integrates the probability of jumping from a given vertex to another random vertex in the graph into the model. So in the context of web surfing, it uses the damping to create the random surfer model. So a user can click at random with probability D, and then they can jump to a completely new page with probability 1 minus D. This essentially allows the surfer to keep moving even if they reach a page with no links. So they can move to a different page. They don't get stuck. It also acts as a kind of smoothing. So now that we have seen the update formula once, we can move in with a little bit of a more detailed sample graph, and we can go through, and so you can really see. So let's pretend that this is a graph of web pages with each letter being a web page. So we have the update formula on the right here, and D is our target node, so D is VI in this case. In VI is all of the nodes that point to D, so all of the red nodes in this graph. These are the nodes that we're summing over to get the score for D. So let's say we're at the E part of the summation portion of the PageRank update. So VJ, in this case, is E. If we look at this graph, we're at the E. We're at the E part of the summation. All of the ones that are filled in now are out VJ. So these are the edges that are going out that we're normalizing by. So in this case, this number would actually just be 3. So we would be multiplying the score of D, which is our VJ in this example, by 1/3. D, just to be clear, is not the damping factor. I'm talking about the node. I realize now that that's a little bit confusing. Okay, so now that we have a little bit of knowledge of how PageRank works, we can go back to TextRank. It also uses a graph representation where the edges vote for the various vertices, but there are no links in sentences. So how do we use these sentences to recommend other sentences? We can use similarity between the sentences. So what we end up with is not a directed unweighted graph like we have with the links. We have a weighted undirected graph, and I'll show you how that works in a minute. This is the similarity metric that we're going to use. It's the same one that Mahalja uses in her paper. So we can look at the numerator. That's the number of unique words that appear in both sentences. And those are divided in the denominator by the sum of logs of the number of unique words in each sentences. In NLP, we refer to unique words as types and individual words as tokens. So you can also say that these are the logs of the types in each sentence. So the denominator here normalizes for the length of the sentences. We don't want to have a high similarity metric just because a sentence has a lot of words in it. So we use this to normalize. Okay, so here are some nonsense sentences. So we can take a look at how this similarity metric looks. So when we plug them into the formula, we get 0.2282 for the first one because there's one letter in common, and that's again normalizing for the length of the sentences. These sentences don't have any words in common, so the similarity metric between these is going to be 0. And then finally, these have 2 words in common, so this is the strongest connection, and it's the highest similarity. So just like with the web server example from PageRank, we initialize with equal scores, and then we iterate through as the text surfer eventually pools around the same sentences. We stop iterating once we converge, and again, we're going to get to that in a second. But in this case, we'd end up with the top left sentence as the highest ranking vertex, the bottom sentence as the second, and the third as the lowest ranked sentence because there's more weight going into the one in the top. So I've mentioned convergence a couple of times. What is convergence in this context? It's basically when the error rate for any vertex falls below a certain threshold in the graph. So these are, again, the scores for each node. And since this is an unsupervised task, we just calculate the error rate as the difference between the scores in this iteration and the last iteration. So when they start to get more similar, then we stop. And it's basically equivalent to early stopping. So let's get to how we get these scores. We use the TextRank update formula. So note here that instead of using S for score, we use WS for weighted score. Those are not 2 different variables. That just stands for weighted score. And you'll see that you see some similarities. The first is that, again, VI is our target node. So just like before in the graph that we're using, which is very similar to the PageRank graph, VI is our target node that we're trying to get the score for. And in VI is the set of vertices that point to VI. Again, this should be looking familiar. VJ is one of the nodes of VI that we'll be summing over. And you can see here we have a weighted score as well. And then here's the part that's the most different. This is the sum of the weights for all edges that are going out of VJ. So instead of counting the links, we're summing up the weights of the edges of VJ. In the context of PageRank, this was to normalize for the linky pages, the ones that had a lot of links, and therefore we didn't weigh their input as heavily as the ones with fewer links. So in this case, it's to lower the influences of sentences that are really similar to other sentences but are not good for summarizing, and it also acts as smoothing. And here again, we use the same damping factor. You can see that the whole algorithm is pretty similar to PageRank, with a few tweaks for being appropriate for a weighted graph rather than an unweighted graph. And going back to our example here, if we went through and did the scores, we would end up with something like this. And you can see the top sentence still wins. OK. So now that we have some of the basic concepts, we can look at some code. And this is adapted from Brian Lester's implementation of TextRank. And if you follow that QR code, there's a link to this in my slides. Okay. So. Okay. All right. Oh, no. Okay. Oops. I normally just do Control-C, but my Control key doesn't actually work on here, so I'm just going to redo this real quick. Sorry about that. Okay. Okay, so we'll start by importing the packages we need. And then we can take a look at some of the sample data that I got. So if you want to see how I got this data, or if you want to make your own data, yes.
Is there any chance you could enlarge that, please? If you can.
I'll see what I can do. Is that better?
Yeah, excellent.
Thank you.
Okay. Can you guys see in the back? Okay, great. All right, so like I was saying, you can, if you want to get this data, or actually if you run my script, you'll probably get different data because it's on a different day. But if you want to see the data, you can go to the GitHub, and I also have a script that you can use to input your own keywords or use your own preferred sources through the News API. Okay, so here's an example of the data we have. It's just a list of sentences, pretty simple. This is an article about a volcano. And I just used the keyword science because I figured it would be kind of neutral, though I think some of these, I would not classify them as science articles, but that's okay. Okay, so let's get into the Python. So this function calculates the similarity metric that we discussed before, just the overlapping sets of the two sentences normalized by their lengths. This function normalizes a token by lowercasing it and removing non-alphanumeric characters. This one basically uses that one we just ran on every token in a sentence and then rejoins them. This one builds a vocab mapping tokens to indices. So this orders the nodes of the graph, and the index corresponds to where it first appeared in the tokens list. Okay, now we can create the graph. First, we're going to create a vertex object, and the vertex object has properties relating to the update formula. So if you'll note, we have a couple functions within here. the edges out and the edges in. Those are related to the formula that we talked about. This makes our calculations more efficient, and you'll see that it runs very quickly when we get to the actual running part. Okay. And then we create a graph object here using the vertex class that we just created. I'm not going to go through all of the details. If you want to look at this later, you're absolutely welcome to. It's all on GitHub. Also, my scrolling is not super fast right now for some reason. Okay, so you can use a number of different types of graphs with TextRank. It's very flexible, but for our example, we're going to be using an adjacency list that inherits the graph function above. So again, just a reminder that the vertices are the sentences in our data and the edge weights are from the similarity metric above. Okay. So now we can get into the actual TextRank parts. This function calculates the total weight for a collection of edges in the graph. So if you'll recall from before, when I closed the window, that's the normalizing originally for the linky pages and now for the large number of edge weights. Or not number, large proportion of edge weights. This function accumulates the scores from all nodes that have incoming connections to a given node. So this is the summing over the NVI that we talked about. Okay. And then this function sort of initializes the outgoing strength for the adjacency list graph. So in this case, we're going to initialize the weights with a uniform distribution, just how we used 1/3, 1/3, 1/3 for the toy example. And it doesn't really matter that we do this first because the sum of the weights for outbound edges for a given node don't change. We're only updating the scores as we go. So we can compute this first and reuse it. And you can see this is the WS and denominator that it returns. And then we use that information here. And then this should look familiar because this is, again, our TextRank formula here. So this is the update formula. This function outputs the TextRank scores for each of the vertices in the graph. And then this function actually runs TextRank. So this is where we put in all the good stuff like the damping, the convergence type. So I said before we converge when we get to a certain threshold for any of the nodes in a vertex, but you can also do it for all of the nodes in a vertex. There's some other neat features that I won't really get into right now, but so this is just where you put in all that information. And then stepping back to our specific data, this function will create the graph out of our specific sentences. And finally, we have a summarize function that will return the summaries for articles. So this is the good stuff. Okay, so that was all of this implementation of TextRank. We're going to run it on our data now. And I'm going to get back to my slides real quick. Sorry, so one more change of this. Thank you for bearing with me. I know this is like a little painful. Okay, so I just wanted to look at the output of some of the summaries, just to show you how this thing really works. And I I don't know if you can all see that. I'll just read it out loud in case some people at the back are having trouble seeing. It says, Volkswagen is partnering with the University of Tennessee and the Oak Ridge National Laboratory to create the company's first innovation hub for developing new technology in North America, officials said Friday in a statement. Working with the University of Tennessee and Oak Ridge National Laboratory is a great opportunity to continue growing Volkswagen's engineering footprint in the North American region, said Wolfgang Demmerbauer-Abner, VW's Executive Vice President and Chief Engineering Officer for the region. So, how do we feel? Pretty good, right? I feel like we have a pretty good sense for what happened in that article, and I haven't read the rest of the article, but I don't feel like I necessarily have to. So, I mean, this is just a good example. I can show you one more example that I thought was pretty good. Actually, I'm not like cherry picking here. They were mostly pretty good. So this one says, schools and businesses shut across the Philippine capital on Monday as a volcano belched clouds of ash across the city. And seismologists warned that an eruption could happen at any time, potentially triggering a tsunami. Thousands of people were forced to evacuate their homes around Taal, one of the world's smallest active volcanoes, which spewed ash for a second day from its crater in the middle of a lake about 70 kilometers south of central Manila. So again, I think we have a pretty good idea of what happened. We have a lot of the 5 W's you talk about in journalism. Who, what, where, when, how. I don't know if how is a W. I don't remember what the 5 W's are, but it is? Where? Okay. Yeah. The point is we have a lot of information here. I think it's pretty good. So you can see that for a fairly simple algorithm, and you don't have to use GPUs or anything, it runs really fast, you get a very good quality summary. In the interest of fairness, I chose a bad one, but this was not typical at all. So I'll just read it out loud again. In every country where we have a business presence, we're committed to complying with the applicable laws and regulations, and Canada is no different. Howe said, regardless of the decision, our position is we will continue to serve our customers in Canada with our products and networks. I don't know what's going on in that article. I'm not sure why they're bragging about following laws. I don't know what the products are. All I know is Canada. So I guess this one was not such a good summary, but I actually had to dig for this one. So I think that actually says mostly good things about TextRank, because this was really the only one where I really had no idea what was going on. Yeah, it could be that the article wasn't good. We always have other people to blame. Just to, I was actually kind of hoping there would be more of these, because I tried to do it in 3 different sources with the word science, but it turns out there's a lot of science happening in the world. But these are 2 articles about the same story. And they were actually both from Reuters. They were just in different places. So one was took place in Manila, and one took place in Tagaytay City, which is where the actual volcano is. And I guess I'll read these aloud too, because the text is a little bit smaller. We actually read the first one earlier, so I don't have to read that one. But the second one says, we prayed that we can rise up, put a stop to this calamity, and allow us to return back to our homes, said 44-year-old evacuee Annie Villanueva. A lot of families like us want to be together in our homes and stand up. More than 70,000 people have been evacuated since the Taal, one of the Philippines' most active volcanoes, began spewing clouds of ash, steam, and gas on January 12th. So we get some of the same information between these 2 stories. And again, TextRank is running only on 1 story at a time, so it's not like it combines these. I just wanted to see how the algorithm would hold up between 2. And you can see some of the same information. They both mention the name of the volcano. They both use the phrase spewing ash. So that's kind of interesting. And you basically, there's a little bit more of a personal angle to the second one, but that's, I think, says more about the way the article was written than it does about the algorithm. So, but I think since they contain some of the same information, that's pretty good. I think that says good things about TextRank as well. Some other details that I thought would be interesting to throw in here. So 33% of the summaries contain the first sentence. And you can kind of see that here, right? So like Manila Reuters. I left that in there just so you could still see it. But 33% of the summaries did contain the first sentence. And in fact, that's actually an accepted, pretty strong baseline in summarization. It's if you just summarize with the first sentence of an article, in news articles specifically, that's called lead 1. If you have 2, it's lead 2. If you have 3, it's lead 3. So I think that's kind of interesting that 33% of the time TextRank honed in on that. Yes.
Would that still be the case if you reverse the order of the sentences or change the order of the sentences? Any thoughts?
I don't know. What do you think, Rada?
So we looked at the order and how for news articles, I think it makes sense to have the order going toward the first one because that's where typically news articles would have the important stuff. Whereas, for instance, if you talk about movie reviews, we've done some experiments and pointing the other way around makes sense because the essence would be toward the end of the document. So that's a little bit of knowing your data, to think of how to represent the data before you have that.
Can you repeat the answer?
Oh, I'm so sorry. So for news articles, it makes sense to point towards the first sentence because that's where you get most of the information, but it depends on the data. So in movie reviews, you tend to have more of the summary happening at the end. So it depends on your data. It's a matter of knowing your data. Did you also hear the question?
Yeah, the reverse word thing?
Yeah.
So if it's a reverse sentence, does it have the same weight as...
A reverse sentence or a reverse like order of sentences?
If you reverse... both ways. Reverse the word of the sentence or reverse the words of the sentence. Like, would that carry the same weight in the calculation?
So for the words in the sentence, it should be the same similarity metric because it's a set of unique words overlapped. So it doesn't take order into account, the similarity metric. If you reverse the order of the sentences, it does make a difference.
Wouldn't it, if you reversed it and it was a news article, wouldn't it just pick the last sentence, the summarization algorithm, because that's where all the or not? You know, 'cause it seems like that's how it's written to pretty much summarize the news article and then put in detail. That's what I'm thinking. But you'd just have to run the experiment, I guess.
I would say it's probably also a matter of what kind of implementation you have here, and over time with the experiment with the number of settings.
Do you want to borrow this for a second?
So you talk primarily about the undirected version, where it really assumes that you would have, if you think of the PageRank graph, you have edges going both ways, right? So you have two sentences, you connect them, and you work with them as if there were edges going both ways. But then you can also think of directed graphs, and then you can add direction depending on, like I said, on the data. So for news articles, for instance, you could, given two sentences, you would still have the similarity, which is what you talked about, but then the direction of the edge would go from toward the beginning of the text, right? So say sentence 3 and sentence 1, it will go from 3 to 1 because 1 happened earlier. Or you could also have it the other way around, right? So going toward the end of the document, and that would make sense, like I said, for movie reviews or other types of documents where the essence of the text tends to happen toward the end as opposed to toward the beginning.
Did anybody else have any questions for Rada? That's the Michigan difference.
Yes.
Okay. I have just a couple more things, and then we can talk some more if we want. So basically, anyway, this is an accepted baseline called lead 1. And it's interesting that 33% of the summaries contain the first sentence. I think lead 1 would have made a really boring PyData talk, which is why I didn't do it. But And 17% of the summaries contain the first sentence as the highest ranked sentences. So actually, quite a few of them, even if they contain the first sentence, decided to rank another sentence higher. In the code, if you run it yourself, there's a variable called keep order. So that will maintain your sentences in your summary in the order they were in the article originally. And you don't have to do that, but that is something I kept for these summaries. So these might actually be in different orders if we didn't run keep order, but I decided to run keep order. Okay. Something else I was kind of interested in was about the summary lengths. So only 2 of 58 summaries had an average summary sentence length shorter than the average sentence length for the data they were in. So we do get, I guess we get a little bit of an effective length, but to be honest, I think it was okay because the summaries we got were pretty good. I think sometimes just the longest sentence is the best summary. So not really sure what else to say about that. But overall, I think that the summaries were pretty good quality and surprisingly coherent for a fairly simple algorithm that just extracts sentences. And I think it's a really good option for something fairly simple and very quick. And that's all I have. Questions?
So given what we were talking about with like the sort of the lead model and things like that, like, and then when you were looking at the outputs, we were saying like this looks good or this like seems good. So if you were to compare this model to like a lead 2 model, since we're doing 2 sentences, how could you do that? Like, or is there a way to do that like in a fairly objective way to see like, you know, how much better is this than a lead 2 baseline?
There are evaluation metrics. I didn't really write much down about them. I think they're in the paper, though. I can pull it up, maybe.
That's okay. That could be my homework.
Yeah, there are.
Also say a few things.
Yeah.
It's, for extractive, you can do very much like for instance, document search, precision. So usually in this evaluation data sets, they are human references. So it's people who summarize the documents, and then you would compare, say, the lead 2 against those summaries, and then say a TextRank output or another summarization output against those references. And you can do that a number of ways. I think the more widely used ones are when you look at sentence level, really looking at the human reference, which are the sentences that they selected versus which are the ones that say your algorithm selected, whether it's the lead 2 or another one. And then there is also, and that works also for abstractive summarization, where you look at the overlap of tokens. And that's the blue or rouge. There is an entire spectrum of colors for algorithm. There is orange, and I've heard recently also of the bird blue, which adds also embeddings.
You can't compare the 2 unsupervised approaches in an unsupervised way.
Well,
You need a ground truth.
you could compare them, but then it doesn't tell you anything other than whether they are similar to one another or not. But it's not telling you whether one is better than another one with respect to whatever we would consider to be a good summary.
Craig? I can't remember if you touched on it in your intro, but is there a sensible way to maybe combine PageRank and TextRank to sort of get even richer summaries, maybe across different outlets that might have different points of view or something?
I'm not sure how I would combine PageRank and TextRank because they're already pretty combined. Unless you mean like, can you expand on that a little?
So say you have 5 articles about the same thing, and you want a summary of that thing from all of those articles. How can you sort of combine the TextRank within each and the PageRank between all of them?
Oh, like you have a Google search and then you choose the best page and then you do TextRank on that and get the summary? Yeah, you could do that. I don't see why not.
curious about if there were limits to the article size.
No,
Just because of the equation, it seemed to, at least in my head, it seemed to indicate that each node, each sentence was connected to every other sentence. So you had to run through various combinations, basically.
yeah, I mean, I imagine you would eventually be limited by computational power, but I think it's so fast right now that it would have to be a lot.
About like a book.
I don't, just take my code and try.
Well, that's something that I would have mentioned as a challenge for this group. If you want to, I mean, I'm super proud and happy that TextRank works so well, and that was in our experiment for shorter documents. But we also worked on books. I had a PhD student who's done his entire thesis on books, and there is much harder. So if you are up for a challenge, try it on books and see how it doesn't work that well and how you could improve it. And it's also because there is a lot of topic changes. It's not like in a news article, you just have one topic in general. And so the way we've done it is to first do topic segmentation and then do summarization and then try to combine it. But it's still, when you look at the summary of a, say, 400-page book, it's okay-ish, but it's not as great as the one that you've seen. So that would be, whoever wants to try, I'd love to hear more.
How well does dimensionality reduction work on something like this? Where you get sentences that are close enough where you just combine them, and that way you can reduce the number of things you're trying to compare. How well does that work with a PCA or something like that?
We haven't really tried that particular way, so we tried other ways of trying to reduce the size of the problem.
Yeah.
Segmentation was one thing, like try to cut the text into smaller pieces, but it still doesn't work as well as on news articles.
What would your input features be for a PCA approach?
Let's talk about that after. Were there any other questions for Amy? Mike?
I guess my question is, are there other applications other than like summarizing news articles that you've come across or you can think of? One came to my mind was maybe if you're out of the loop and you want to find out what the newest hashtag on Twitter is about, you could maybe get a good summary or the top 5 most related tweets. I don't know. Do you have any other ideas?
I don't know about that. I mean, I guess if you... I don't know if I would use it on tweets because they're so short anyway, and it's like it's not like a news article where they would all be connected. I mean, I guess you could maybe use it. I don't know what the results would be like.
Are you treating each tweet as its own sentence?
Each tweet would be one sentence, and then you basically want to say like, what does first world problems mean? And so you find a whole bunch of tweets that are representative or have that hashtag. I don't know if there are other applications.
I can actually answer that question. When your meetup came in, I said, oh, this text, I'm working on learning NLP by analyzing survey comments. And when you talked to him, I said, what is TextRank? I said, sounds cool, grab some sample code and run out of the survey comments, which are generally short. The results are nonsensical because it's looking for a sentence in very ungrammatical, short snippets. I didn't know what the method was really doing, so I just threw it in and got gibberish out.
Brian?
So in this update formula, we have this normalization. So that's clearly going to take care of like sentences that are very similar to stuff because they're really bland. But it seems like what this is going to do is kind of select out sentences that are very similar to each other. Did you notice like similar, not similar to everything, but just to another? Have you noticed like problems with like diversity in sentence? Like are all the sentences in the summary like pretty samey? Like does each sentence really add that much information?
Good question. We can look at some if you want. I thought they were mostly just very summarizing, not so I mean, like some of them are just really long. So, I mean, I think that the one that I actually showed as a bad example was a very bland, samey sentence. Like, there's nothing going on here, except maybe a lot of the other ones have customer and regulations and business and all these. So this was, oh, I'm sorry. I thought I was on the mirror one. Hold on a second. This one. I think this is a good example of maybe where that could have happened. Where you don't get very much
Also
information.
notice that if you do multi-document summarization, say if you have 10 documents on the same topic, and then there will be more redundancy that you see in one single document, and that's a good point. So we've noticed sometimes they talk about the same thing to go into the summary, so then we had to apply ways, to find ways to remove that. So if two sentences are too similar to one another, we'll actually get them out of the summary for this reason. That's what we observe here. In multi-doc summarization would be even more frequent as a phenomenon.
Did we all hear that? No,
But-
okay. So in some longer documents where there's a little bit more repetition and redundancy, TextRank sometimes pulls out things that are similar to one another but don't necessarily summarize the document well because there's so much repetition, and it doesn't necessarily work as well as the news articles that are a little bit more concise. So they've had to use other methods to deal with
I
that.
meant even like multi-document. So you have 10 news articles, you put them together,
Oh, okay.
and then you apply the algorithm, then you
That is also the case if you do multiple documents and run the algorithm on multiple documents instead of one at a time.
So I know I learned a lot about TextRank, and I also learned a bit of backstory from Radha as well, which is back in 2004 when it was published, right? That it took about a week to write the code and test, and another week to write the paper, and the next thing you know, with longevity of the work, there were like 3,000 plus citations, right? So we can all aspire to being that not only efficient, but producing work that sort of lasts the test of time. But with that, let's thank Amy for another great talk.